Hello, I am Pankaj Sharma from PM Expert. Today we will understand the chi-square distribution, why it is always positive, and how it is used in statistics. First, where does chi-square come from? Imagine a standard normal value called z. If we square it, it can never be negative. If we add up several squared z values, the result follows a chi-square distribution. Here is the defining formula. The number k is called the degrees of freedom. It tells us how many squared pieces are being added. When k is small, the graph is very steep on the left, and when k is large, it becomes smoother and more bell-shaped. Now, let's draw our chi-square curve for k equals 5. Notice how it starts at 0, then rises, and has a long right tail. Key characteristics. It is always positive. It is skewed to the right. The mean equals k, and the variance equals 2k. When we compute a chi-square statistic from data, we use observed minus expected squared divided by expected, and then add them all together. Here is the formula. Let's do a goodness of fit example. We roll a 6-sided die 60 times. If the die is fair, we expect 10 of each face. Here is the observed and expected table. Now compute each piece. For face 1, we get 0.9. For face 2, we get 0.9. For face 3, we get 0.4. For face 4, we get 0.4. For faces 5 and 6, we get 0. Add them up, and the chi-square value is 2.6. The degrees of freedom is categories minus 1. We have 6 faces, so degrees of freedom is 5. The critical value for 5% in the right tail is about 11.07. Our value 2.6 is much smaller, so the die seems fair. Here is the same chi-square curve with a critical value line. The right tail is the rejection zone. If our statistic falls there, the difference is too large to blame on luck. Why do we reject when the chi-square value is greater than the critical value? Because the critical value marks a boundary of rare outcomes. If we cross that line, the gap between observed and expected is too big to be explained by chance. Is this like the 2 sigma rule? Yes, the logic is similar. Both keep the outer 5%. But the chi-square cutoff depends on degrees of freedom. 4 degrees of freedom equals 1. The critical value is 3.84, which is 1.96 squared. Summary. The chi-square distribution measures the gap between observed and expected data. It is always positive, skewed right, and depends on degrees of freedom. We use it for goodness of fit and independence tests. Thank you for watching.